Now let's look at the flags. See, we are done with the source port, destination port, sequence number, acknowledgement number, and we are done with the header length. And after that header length, there is some reserved field which is not used. There are actually 6 bits of reserved which are not used. And after that, if you can see some flags. One flag is URG, and other flag is ACK and PSH push and RST reset, SYN SYN, FIN fin. So we shall see all these flags. Flags are nothing but one bit information. So what I do is, instead of taking about the flags all together, I'll take the flags one by one and then tell you where they are used and what is their main purpose, and then we shall see like that all the flags one by one. Okay. So first one is, if you look at the last but one flag, it is given as SYN flag, SYN, SYN flag. It is also called as synchronization flag. Synchronization flag. Okay. And next flag, if you see, the second flag is ACK flag. ACK flag means acknowledgement flag. Acknowledgement flag. So these two flags are used in such a way that if SYN flag is set, so I'll just take an example and explain you where they are used here. Let us assume that there is a sender or the client and server. It is a TCP connection, client and server. So TCP is a connection oriented protocol. TCP is connection oriented. So connection oriented means before sending the data, you should tell the other side that I'm sending the data, so you please reserve the buffers and wait for me. So before you do the actual data transfer, you should do connection establishment. In every connection oriented protocol, before sending the data, you should do connection establishment, and after sending the data, you should do connection termination. Therefore, there are 3 phases. One phase is connection establishment. Connection establishment means before sending the data, tell them that I'm sending the data. And second thing is data transfer. Data transfer means where we actually send the data. And the third one is connection termination. Connection termination means after we do the data transfer, we are going to terminate the connection, right? And I'll take some examples here and I'll explain you all this. So maybe note it down. TCP is a connection oriented protocol. It has 3 phases. One is connection establishment, data transfer, and connection termination. And right now I'm talking about connection establishment phase. Okay, you please make a note of it. And how to do this connection establishment is, I told you that sequence number present packets, right? So before starting this every connection, you should come up with a port number. Let us assume that port number at the server is 80 and your port number is X, right? So what is X? X can be any random number chosen from 0 to 2 power 16 minus 1, and in general you need not actually go till some range. Some range is generally avoided. Anyway, this number is going to be chosen by your operating system. You are not going to do it. Even you have the control to choose the port number and assign it to a process, but in general, if you don't do such things, operating system is going to provide you a sequence, this port number, some random port number. And next thing what you should do is, you should take some random initial sequence number. And how are the random initial sequence numbers used is, from the time of the day, from the clock, least significant 32 bits are taken, and that is taken as initial random sequence number. And how is that procedure used? We shall see it later. But for now, assume that client has chosen a random initial sequence number 521, which means from client side, it is going to start the communication with the sequence number starting with 521. And at the server side, it doesn't know that someone is going to contact it at, therefore it will not do anything as of now. So after choosing these two numbers, client will send the first packet. On that first packet, there will be a header, right? So it will contain purely a header. Packet doesn't contain any data. So you are not supposed to send the data immediately. You are just going to send a header. which contains the relevant information, which contains the information required for connection establishment. So what are you supposed to say in this first packet is what is the sequence number you have chosen, and you are going to start communication from that sequence number. So in the sequence number field, so there is a field called as sequence number field in the header, right? Just look at the header. In the second row there is a sequence number field. In that sequence number field you are going to indicate that 521 is my initial sequence number that I have chosen. That is what you are going to indicate, right? And along with this you are going to indicate that this is the first packet, or this is the first sequence number. So syn flag is used to synchronize the sequence numbers, which means here there is a different sequence number and here there is a different sequence number, and both of them should know what their sequence numbers are. Syn flag is used for synchronization. Therefore putting syn equal to 1 is nothing but we are saying that this is the first sequence number I am using. So syn equal to 1, right? And along with this, in the options you are supposed to say few things. If you are present in one network, and if the server is present in other network, in your network according to the data link layer frame, you might have some sizes which are permittable, which means here let us assume that at your data link layer frame, let us assume this client is present inside a LAN which is using Ethernet, and at data link layer the LAN, Ethernet LAN, assume that it has the tail and header and it can carry a data of 1500 bytes, and then in this data link layer frame a network layer datagram is going to commence it. So network layer datagram's maximum size is 1500 bytes and which should always contain at least 20 bytes of header, right? Therefore transport layer segment can commence it in this. So this size is 1480, isn't it? 1480 is the maximum data that the network layer datagram can carry. Therefore transport layer maximum segment size is 1480, out of which 20 bytes is going to be the header. Therefore what is the maximum data that can be present inside this transport layer? 1460. This is called MSS, maximum segment size. So how did we get the maximum segment size? That depends on the maximum that the network layer can carry and data link layer can carry. In case if the data link layer can carry any amount, let us say 1 GB or 2 GB, then the bottleneck is going to be network layer. You please refer to the concept of segmentation and fragmentation in order to understand it better, right? So let us assume that in your network you found out that the maximum segment size is 1460, and you should say that in my network I am comfortable with maximum segment size of how much? 1460. That is what you are comfortable with. You are telling the other side. Why should you inform it to the other side is, other side will now, whenever it wants to send the data, it will not cross maximum 1460. What happens if the other side sends a data of maximum 1460, more than 1460 in one segment is, when the datagram comes here, it has to be fragmented. The reason is network layer is allowing only how much? 1480 plus 20, which means 1500. So in case if the other side sends more than 1460 bytes in one segment, then anyway that has to be fragmented and then assembled, right? In order to avoid that overhead, it is better that you say, see, in my network the maximum size is 1460, you please don't send more than 1460, otherwise I might have to face this fragmentation and reassembly, which is a headache. The problem with this fragmentation and reassembly is, whenever you fragment a datagram into many fragments, even if one fragment is lost, then again everything has to be retransmitted. That is why, and moreover this sorting and then combining, everything is a headache. So we generally try to avoid fragmentation as much as possible. How? By saying the other side what is your MSS, right? And now other side, along with this you should also say what is your size, what is the maximum size you could hold. So where is this field MSS? If you look at the header, is there any field called MSS? Just look at the header. There is no field which is having MSS. Therefore it is kept in options. This field is kept in options. Inside the TCP options we are going to put it. So why are we going to put it in options is, the reason is this: every packet need not contain this MSS. MSS, once it is initially sent, other party will note it down and MSS will not change all the time. The reason is that depends on your network. As long as you are present in that network, MSS doesn't change. Therefore, it is not a good thing that you include it in every packet. That is why they kept it in the options. If you need it, you can use it. Otherwise, don't use it, right? And now after this MSS, one more option is TCP is a full duplex connection. Full duplex connection means data will go in both the sides. TCP is full duplex. Maybe you could write it down somewhere after copying it down. TCP is full duplex. Full duplex means at the same time, even though I am saying that client is there, server is there, it is not always true that only client will get the data or server will get the data. Communication can go on both the sides. Therefore, it is a full duplex connection. Then what happens is, we have client and we have server and we have the connection established. Sometimes receiver is going to be client is going to be receiver, and sometimes the server is going to be sender, and sometimes client is going to be the sender and server is going to be the receiver. Therefore, there has to be at least 4 windows in order to keep track of what is the capacity of each side. So for that reason, the client, whenever it wants to accept some data, server should not send more data than what it could accept, right? So think about it. Server is going to send some data in terms of MSS, maximum segment sizes, or in terms of segments, and now server should not send more than what the receiver can receive, right? Therefore, it is the responsibility of the client to say to the server that don't send me more than so and so bytes. Let us assume that. So there is a special field called as window size. Check in your header. After the flags, there is a special field called as window size, right? In that window size, why that is used is, let us assume that window size is 14600. So what does it mean is, client is saying that I have a window, which means a buffer which can hold 14,600 bytes. Every MSS can contain 1460 bytes, and total my window size is 14,600 bytes. What does this mean? That the sender can send 10 packets or 10 10 segments, each containing 1460 bytes each, right? So how to explain is, see, what I mean to say by this window size is, now there is client and there is server, right? There is connection established, and now the window size is nothing but the amount of buffer the client is reserving for this connection. So this is not the sending buffer, it is the receiving buffer. So now whenever this server sends any data, the data is going to come and sit in this buffer, right? Then how many packets can the server send before it gets any acknowledgement is 10 packets. Now I am saying that the buffer I have reserved for you is 14,600, right? 14,600, and then every packet is of size 1460. Then how many packets can be sent? It means that you can send 10 packets before getting the acknowledgement. So at one go, the server can send 10 packets and client is having the space to hold 10 packets. And if server sends more than 10 packets, we don't have space to hold it. That is why it is called connection oriented. We are even reserving the buffers, right? So here this window size is nothing but what is the capacity of the client as a receiver, right? So why is this window size field used in that header is for the flow control. So window size is a field which is used to indicate capacity of the host as a receiver. Capacity of the host as a receiver. Why is it used? It is used for flow control. What is flow control? We are never supposed to send more than what a receiver is able to receive. Therefore, this field, this particular window size is used for flow control. Later I'll show you by taking a separate example how the flow control works. For now, understand that there is a special field called as window size, and which will tell you the maximum capacity of the receiver, right? So what did you understand from this first packet? We have chosen a sequence number of 521, and then we are indicating that this is the first sequence number I have chosen by using the SYN flag. and then MSS is actually chosen according to the network, in which network I am present, and then window size is 14600. So how did I know that? This is what I am actually dedicating for this connection. So the other party cannot send more than 10 segments, right? Now whenever you send this, the other party is going to reply saying that yes, I got your request and I got everything. Let us say the other side will now choose a random initial sequence number, and the random initial sequence number chosen by the other side, assume that it is some number which is not this one. Let us say 2000. So what does that mean? From the other side they are starting their communication with sequence number starting with 2000. From this side we are starting the communication with sequence number starting with 521, right? So now you should even say that other side will say, my side I am going to start with sequence number 2000 and I got, and this is the first sequence number, therefore sin equal to 1, and in my network the maximum segment size allowed is, let us assume 500 bytes. So what does this mean? The other side is saying that I will not be able to send 1460 bytes. I can send only 500 bytes, and you too please send me only 500 bytes. If you send more than 500 bytes in my network, there will be fragmentation headache and I don't want to face it. Therefore this side is saying 1460 is the MSS in my network, other side is saying 500 is the MSS in my network, then both of them will come to the minimum, which means now both of them should agree for 500 only. That is how it is a kind of negotiation going on, right? And the other side will say, I am also dedicating some buffers for you, and the buffers I dedicated for this connection is 5000 bytes. See, why only 5000? I am just picking this randomly. It need not be 5000, it could even be 10,000, right? So let us say 10,000. What does this mean? It means that the server is reserving some buffers, and the buffer is actually 10,000 bytes, and every packet is containing 500 bytes. Therefore how many packets can the client send at one time? 20 packets, right? So you can send directly 20 packets in one window without worrying about I mean 20 segments, and the other side it is saying that your sender window can be 10. So now depending on the MSS of 500, both of them will choose how many packets should be sent, isn't it? Now both of them should agree for 500, even though it is saying 1460, but since it has said 500, it is and the client cannot send more than this much amount of data put together in all the segments. The reason is they are not able to hold it or handle it. Now where is this MSS set? Again in options only, there is no facility in the header. And where is this one? It is in the header, right? Along with this, the other side should also say that I have received the packet you have sent, which means it should even send the acknowledgement. So it is going to say along with this one acknowledgement number also. It will say acknowledgement number is, see, you have sent 521, I received it, and I am going to wait for the next byte 522. It is very important, try to understand it. Whenever you send this SYN packet, whenever you send S5 equal to 1, that is also called as SYN packet. So always remember that SYN packet will eat up one sequence number. What does this mean? It means that whenever you send a packet with SYN equal to 1, whatever sequence number is present in that packet, that is consumed. Therefore, if you are sending the sequence number 521, it means that 521 is over. The next data byte will carry 522. Therefore, other side should wait for 522. Therefore, other side when it sends the acknowledgement number, it says that I am waiting for 522. And where is this acknowledgement number present? Look at your header. In the third row, below this source port sequence number, there is acknowledgement number. In that field, we are going to put 522. And along with that, ACK flag will be 1. So there is a flag called as ACK flag. Both are different. Acknowledgement number is a field which is 32-bit field, and ACK flag is 1 bit. So where is this ACK flag present? In the 1, 2, 3, 4. Fourth row you can see that ACK flag. So ACK flag equal to 1 means it indicates that the acknowledgement field in this packet is used. In this one I am not mentioning anything about ACK equal to 1. The reason is, when you are sending the first packet, you are not sending any acknowledgement on the packet, right? Why? Because you don't know what to acknowledge. It is the first time you are sending a packet. Therefore, other side is going to send you the acknowledgement, therefore ACK equal to 1, but your side you are not sending any acknowledgement, therefore there is no ACK field here. So just remember that on every packet we are going to put the acknowledgement number on the header. It is also called as piggybacking. Piggybacking means whenever you are sending some packet, on that data packet itself you put the acknowledgement, that is called piggybacking. Therefore TCP uses piggybacking acknowledgements. Piggybacking means on the data you can put acknowledgement, or sometimes it will send only pure acknowledgement. So what does this mean is, if someone wants to send you the acknowledgement on the data packet itself, if it is the data and if it is the header, on the data packet itself they can put the acknowledgement. This is called piggybacking. Or if they want to send only the pure acknowledgement, what they could send is, they could take the header, and in the header they could put the acknowledgement and they can send it without any data. This is called pure acknowledgement. Therefore TCP uses both piggybacking acknowledgements and pure acknowledgements, which means whenever the other side has to send some data, on that data it will put the acknowledgement, that is called piggybacking. If the other side does not have any data to send, still it is supposed to send a acknowledgement. Why? Otherwise there will be a timeout on the other side, right? That is called pure acknowledgement. Okay. So now with this the reply is finished and you are supposed to send acknowledgement. So what is the acknowledgement is, you should say that yes, I got your parameters and I am comfortable with that. Let's go ahead and finish the connection. That is the meaning of it. So what should be the sequence number on this? Sequence number on this is, already you started with 521 and 521 is over for the first SYN packet, and now you should use 522. The reason is, other side is expecting 522, therefore your sequence number is 522. And what is this packet? This is the acknowledgement packet, therefore you should even put acknowledgement number. What is the acknowledgement number? Other side has sent 2000, therefore you should take 2001. 2001 is your acknowledgement number, which means other side you have received 2000 and now you are expecting 2001. And you should even say that this packet contains acknowledgement. This ACK flag indicates that this packet acknowledgement field is valid, please check it. If you put ACK equal to 0, it means that whatever field is present in this acknowledgement on this packet, that acknowledgement field, you please don't look at it, it is not used, right? And almost every packet will use the acknowledgement field. So 3 messages have been exchanged. So what is the main purpose of this connection establishment? How is connection establishment done? You are choosing a random initial sequence number and sending that sequence number. Along with that, you are sending some parameters like what is the maximum segment size in your network and what is your capacity as a receiver, so that the other side can send only maximum of this much size in one segment, and they can put all the segments together. Data should not exceed this much amount because you have only that much buffer to hold it, right? And the other side is sending their sequence number. Both of them can start with a random initial sequence number, right? And they should say this is the first sequence number I am using it, and according to their network parameters they can derive this MSS, and then they can say this is the maximum. So what does this mean? It means that you can send the segments of size this much, and all the segments put together they should not exceed this much. That is the capacity of mine. And along with that, they are even sending the acknowledgement. So one important thing which you should be careful about this is, always remember this, SYN packets. SYN packets means any packets which has SYN equal to 1 will consume one sequence number. Please remember it. And second one is acknowledgement packets, which means if it is a pure acknowledgement like this one, that acknowledgement packet will not consume any sequence numbers, which means even though this acknowledgement packet is using 522, it doesn't mean that 522 is over. You can again use 522, right? So So next time when you send any byte, this 522 is still available. 522 is not yet over. That is the second point. And fin packet. Fin packet I'll show you at the end. Fin packet, whenever the packet has fin equal to 1, it consumes one sequence number. And every data byte, one data byte will take one sequence number. Just keep it in mind. Synchronization packet will take one sequence number. Acknowledgement packet will take 0 sequence numbers. Fin packet will take one sequence number, and every data byte will take one sequence number. Therefore, if it is a pure acknowledgement, it means that no sequence numbers are consumed, which means this is a pure acknowledgement, which means that the sequence number which is used, 522, is not yet consumed. It is just sent, but it is not yet consumed, right? So just observe this. The first message which is sent from here to here, it is called first packet or request packet. And the second message which is sent from here to here, it is called a reply packet. And the third message which is sent from there, it is called acknowledgement packet. So after sending these three packets, connection will be established. Therefore, it is also called as three-way handshake. Three-way handshake means first message, second message, third message. After these three are over, then the connection is literally established. So after establishing the connection, we are going to do the data transfer. Now we shall see how the data transfer is going to happen. What I'll assume is, I'm just continuing the procedure. What you could do is, in your book, you can continue this timeline. Timeline is going from top to down. In your book, what you could do is, you can continue this timeline diagram, but then what I'll do is, I'll draw it separately, which means after this connection establishment phase, immediately data transfer will start. But then I'm showing you differently because I don't have space to show here. Okay.